If you're over 35, between 30 and 35. Maybe if you're over 40, you definitely experienced the golden age of games. The best time to be a teenager on this planet, which was the arcade era. Do you agree with me? Yeah, right? And also the era of 8-bit and 16-bit game consoles. It was an amazing time, and if it makes you nostalgic, then you remember how much fun we used to have. Whether it was going to the arcade, buying tokens and hoping to get as far as possible on a single token, or going to the video game rental store and paying for an hour to play Super Nintendo, NES, or Sega Genesis. Do you remember those days? So, I basically decided to go back to my teenage roots and fulfill a long-held childhood dream I always had, which is to have my very own personal arcade machine at home. And I did it using 3D printing. I printed my own arcade machine. That's what we're going to see. So stay tuned and let's check out how I put together an arcade machine using my 3D printer and loaded it with over 1,000 games. Games from the NES, Super NES, Nintendo 64, Mega Drive, Master System, and of course, the arcade classics. Those were the ones we used to see at the arcades, the ones we went there just to play. But you can actually add a lot of other games in there, games that some people don't even remember anymore. From consoles like Dreamcast, Game Boy, Game Gear, Neo Geo, Sega CD, remember those? So we can put all those games, those emulators, inside this personal arcade that I'm now going to be able to play right here in the garage. And if you also want to build this project at your house, welcome to our video, where I'll explain how I put it together, what challenges I faced, and how you can do it yourself using your 3D printer. So, without further ado, let's invent. This is an open source project that you can download for free and print entirely on PLA, meaning you don't need to use any kind of super complicated material or anything that's going to warp or cause roping, none of that. This one here I printed entirely using PLA, except for my little sign up here. That is made of translucent PETG, so we can get that more retro light up effect and really give our arcade machine its character. This is just the first video in our Winter 2026 series. There are more videos from this series coming up, but I'm not going to spoil, okay? There are some surprises coming, so you can have fun this winter too. And this is just the first video in this series that I'm bringing to you here in the Inventor's Garage. When I started this project, I started it with the intention of designing my own arcade machine. But there were challenges right from the start, because here's the thing, I wanted to design my own arcade machine and I wanted it to be possible to make it available to other people so they could also print and enjoy this project. And since I had the K2+, I thought, hey, I'll be able to make much bigger parts with a 350 by 350 millimeter area, so I can take advantage of that to print. But if I made parts that were simply too big, most people wouldn't actually be able to print them with a smaller printer, which is a common limitation for many hobbyists. And the challenge was to be able to build an arcade machine that was truly full-sized, not just those little toys or mini versions you sometimes find on most websites to download. And at the same time, it had to be made of individual parts that could be printed on a regular-sized printer, not only on a giant industrial printer like the Creality K2+. And of course, besides that, it needed to be easy to assemble. It had to be compatible with components that are easy to find on the market, like the joysticks, the monitor, and all the other parts that make it up. I'll explain to you in a moment what I had to buy and what I reused from previous projects to put this machine together. But this project needs to be something that's easy for anyone to assemble. And then I started thinking, man, it's going to be quite a prototype. It's going to take a lot of printing to test and validate until I can get to the final model. I then thought, should I stick with it? Is there really anything out there on the internet that we can use or at least adapt? So I wanted to do some digging on the internet, searched for arcade projects, and came across this project from LipTech. Man, it has everything I wanted to develop in the project. First, it's actually quite easy to assemble this. You'll need glue and a few screws to carefully secure it, and some specialized components, such as the Raspberry Pi board itself, which is the main component to run the games inside the machine. You'll also use a few screws to attach the monitor and other parts. But overall, the entire assembly process is done primarily using glue, making it a straightforward and simple build. And the project is pretty well put together. It has its flaws, which I'll talk about in a minute. I'm going to warn you about some problems I faced while assembling the project, but overall, I'd say it's a project that would easily score a 9 out of 10. Of course, if I were actually rating the quality of the project, right? But I'm not. And the most important part, you can print this entire project using a printer with a print area of about 260 by 260 millimeters. In other words, it's compatible with a printer like the K2, for example. And the K2 Pro, which has a 300 by 300 area, will print it easily too. But when using a K2 Plus 3D printer, there are certain assembly files that I managed to successfully reduce from 4 build plates down to just 1 by carefully putting everything at once on the K2 Plus's bed and printing it all together in a single run. So, I was able to split the work between the K2 Pro and the K2 Plus end. I managed to finish the project way sooner than I would have if I only had a printer with a 260 area. But let's get to it. Let's start with the warnings, okay, and the progress of this project's development. First of all, it's not a project where you just set it to print one day and the next day you're already assembling it. That's not the case. It's really big. It's a huge one. There are a lot of files there. The advantage is that the files already come in 3MF format. They're already separated and painted so you can have a theme. Then, of course, you'll choose the filament colors you have or decide to buy to print the project. But it already comes with the parts inside the 3MF file already pre-colored. The only thing you need to do is change it to the color you choose and then send it to print. When it comes time to assemble it, like I said, it's super simple because everything just snaps together and is glued. And the designer made the joints between the pieces using some dowels, which you'll print yourself, of course. And there, you add glue to join the pieces together and make it take the shape you see here. My tip is this: use a strong adhesive epoxy glue, such as the well-known brand Araldite, or you can also use cyanoacrylate super glue, but make sure it's specifically the flexible version, which is a new type that's coming out on the market. It's super glue, but with more flexibility, specifically so it can handle twisting and pressure, okay? In this version of the project I put together, I bought a box of small tubes of this glue. First, because I wanted to measure the exact amount of glue I was going to use. And second, because it was on sale, so I bought a box that comes with a bunch of packs of this super glue. I used exactly 28 grams of this glue, and I'll tell you right now, I didn't hold back. I really slathered on the glue because I wanted the project to be really solid, really sturdy. But I don't recommend that you buy those little 2-gram tubes, okay? So I'm telling you now, you're going to use about 28 grams of super glue. So go ahead and buy the bigger tube. It's more economical that way. It's cheaper, lasts longer, and you'll still have some left over if you need it, alright? Besides that, you'll also need some M3 and M4 screws and a few inserts. You know what an insert is, right? It's like a little nut made of brass that you melt and set into the plastic so you can screw into it later. To make this cool LED down here that looks like the underglow on Fast and Furious cars, I reused some LED strips I had left over from another project. I also used 2 additional smart lamps so that I could put one behind the sign and another one below the joystick to help light up the joystick panel. These were also 2 smart lamps that I already had, and I used the sockets from our previous projects. This way, I was able to make use of what I already had available, and the setup became cheaper. By the way, if you're not subscribed to the channel, go ahead and subscribe, hit the bell, and since your finger's already down there, please give a like and a hype to support our work. Deal? Awesome. The monitor is a cheap one, even though it's called a gaming monitor, okay? But it's a 22-inch gaming monitor, full HD, with a 5 millisecond delay, alright? But it's a really cheap monitor. I paid less than $80. I'll leave the link here in the description. Actually, I'll put all products in the description. The full list of links to all the components I used. So you can click and check it out. Make a budget if you want, alright? Especially since there are people who aren't from Brazil watching this video. So I'll leave the links there so you can click and go to the AliExpress page or even eBay. And you can check out the detailed specs of the components I bought for your reference. For example, the Mercado Libre products doesn't deliver to Europe. So if you're in Europe or the United States, please note that you can look at the description, review the specs, and try to find them on your local marketplace. And the way we can fund this work is through the use of affiliate links, where you help us every time you make any purchase on these marketplaces. Start by the Inventor's Garage store. Just click on our links and make your purchases. This way we get a small commission. So we can invest in things like this. Bring them here and make your life more fun. Besides being useful for 3D printing, of course. 2 more quick tips here for when you're assembling, which I forgot to mention, so let's go. First, there are the dowels, but they come oriented on the build plate to print standing up. Don't print them standing up because they'll end up weak. And when you're putting the pieces together, if you force it and end up applying more pressure, right? Because the adhesion between layers is weaker, you end up breaking the dowel and you'll end up losing both pieces. So my tip is to cut the dowel lengthwise and lay it down on your build plate. Then duplicate it again for however many you need. This way, the print will be on its side and the dowel will be much stronger. And once you put it in here, there's no way anyone's breaking this dowel in half, alright? Another thing is, there's a very specific spot in the project where the designer left one of the dowels going right through the middle of a hole. You have to fit one of these pieces here, so I had to cut a part of the piece so it could fit past the side of the dowel. So take a look at that. Maybe it's worth cutting the dowel before you put it in place so the hole stays intact. But I'll show you on the screen so you know what I'm talking about. When you're putting your project together, pay close attention to this part. That way, you can have the dowel already cut and won't have to cut the piece that's going to fit in there, okay? Another tip is when you're assembling, there are some parts that will be a bit trickier, let's say, to put together, especially when you're joining the last pieces together. So, you'll first assemble the sides, the panels, and then you'll join those 2 sides together with the connectors in the middle. When it's time to join the 2 sides, sometimes it's harder to fit them together. Some of the connectors are a bit tight. And this genius here decided to give it a few taps to help it fit together. But I forgot to put something underneath for support, okay? And then, when I hit it, I remembered that this is PLA. And PLA is a dry, brittle material, not impact resistant, not like ABS. And I ended up making 2 holes in the side, right at the final stage of the assembly process. And obviously, I wasn't going to print the whole side again just because of those 2 little holes, which didn't affect the equipment's functionality. But my tip for you is this. When you do this, if you're going to do it, try to get a small wooden board, place it on top of the plastic, and then hit the board with the hammer. That way, the pressure and the impact, the kinetic energy from the impact, will dissipate across the surface of the plastic without making holes in it. You can also use a piece that went wrong, one of those big pieces that didn't turn out right, and you can use it as that board. Just place it on top of the plastic and hit it with the hammer on that part, since it's going to be thrown away anyway. That way, you don't damage the plastic that will stay in the project. Another important tip is that inside it there are several small pieces, which are reinforcement parts. There's a build plate that's just for reinforcement pieces. So you can support the panel here, which is where you'll rest your hand. So underneath it, there's a reinforcement piece. On the sides, there are also 2 small reinforcement pieces to support the panel. In the back, on the inside, there are some little supports so you can run the cables through and keep them organized. All these components, my tip is to leave them for the very last steps. After the project is already assembled and you're about to fit the final pieces in place, that's when you come in with a marker. Mark the position to glue these reinforcements, because the designer didn't add a slot for you to know the exact position where you're going to put this. So these pieces, these components, will basically just be glued there without any kind of slot or exact measurement. That's why my recommendation is to assemble the shell first, and when it's time to position these components, then you mark them and glue these reinforcements. That way, you'll have your little project already reinforced and fun for you to use. And now comes my favorite customization, besides, of course, the little Inventor plate up here. But the plate? I literally had to design it from scratch, because the plate that comes with it, he just sends a plain plate, but I wanted it to be translucent so the light could shine through the plate. But in the particular piece he designed, specifically on the inside of it, there are some random letters that, when slicing, would get in the way of the light projection. So this one I had to redesign from scratch, took the measurements, went there, quickly drew it up, boom, sent it to print. And it turned out super cool, didn't it? It's easy. You just need to take the measurements and use your 3D editor. But besides the Inventor's little sign, the Inventor's logo here on the side, which I put where there's a little holder for 2 buttons. There are way too many buttons in this project. So there are 2 buttons here on the side, and there was 1 more button here in the middle. But since I'm using RetroPie, which is a project where you can basically interact with the system using 6 buttons, a start button, and a select button, those extra buttons weren't really needed. So I put the Inventor's logo here on the side, and I took the opportunity to do something really cool. I decided to add a USB panel. You might ask, why a USB panel? Because since it's a Raspberry Pi, if I want to do some special configuration on it, change something, or run in system update, it's nice to have a keyboard. And so you don't have to take it out of where it is, open the maintenance cover, and plug in the keyboard and mouse there. I decided to put it here in the front. 2 little USB ports using a USB extension that comes from the Pi board. This way, I have 2 USB ports available in the front, both for connecting a keyboard and mouse, and also if I want to use joysticks and plug them in to play with a joystick, for example, or other devices. You know, there are games that aren't really fun to play with an arcade joystick. It's way better to play them with a joystick like the ones from the Mega Drive or Super NES. Don't you agree with me? So here we have 2 little USB ports in the front, super easy to plug in the joystick, and play whatever game I want. Using whichever controller I feel like, the one I find most comfortable to play with. And the last customization I made was adding adjustable feet. So, what I did was design for adjustable feet, and I used the hole, which was supposed to be for the insert. Actually, I used it to allow the screw for the foot to go in, so I could use it for adjustment. And to finish it off, on the bottom part, I took advantage of my K2 Plus and how easy it is to print TPU. And I printed its little base in TPU to give it more grip and keep it steady on the table, because when I'm playing and getting a bit excited, I don't want my arcade machine sliding around on the table. And don't worry, all the customizations and components that I designed or modified to make it work better, even with components available here in Brazil, like the part for the power socket connector. I'll leave a package available for you to download for free on the GarageM website. Okay, I'll leave the link here. It's in the description. Just click there, download it, and get all these customizations. And take the opportunity to build your own project as well while you're at it. The assembly was super easy. The electronics were simple to put together. The measurements for the buttons here on the front panel, both the buttons and the joystick, are spot on, including the little support for the joystick board, which has a small controller board, all perfectly measured. Now, for the Raspberry support, the Raspberry case was a little tight, but nothing you can't fix with a mallet, and the Raspberry fits right into the case, no problem. Okay, just kidding, but let's move on. In this project, I used a Raspberry Pi 3. Yes, I tried running RetroPie on a Raspberry Pi 2, but man, the Raspberry Pi 2 is just way too slow, okay? You can run 8-bit games, alright? So, the NES games runs just fine, it works well, but when you get into 16-bit games, it starts to lag. Sonic, for example, it's impossible to play. On the Raspberry Pi 3, you already get better performance. Not perfect, but it is way better. You can't play 64-bit games, but 8 and 16-bit games run fine. Sonic on the Mega Drive has a bit of lag every now and then, some audio glitches, like in the music, but it doesn't stop you from playing and it doesn't make the game annoying because of the delays. So you can easily play 8-bit and 16-bit games and enjoy your arcade. If you want performance, real performance. Even so, look, if you want to play any emulator that's on the RetroPie list, go for the Raspberry Pi 4, okay? With the 4, you can play pretty much all the games smoothly. Like, there might be one or another game where you can select a different emulator from the emulator list, and that already helps it'll run better, okay? But overall, with the Raspberry Pi 4, you can run pretty much all the games available in the RetroPie library. RetroPie is an open source project, and I'll leave the link here in the description for you to click and check it out. It's super easy to install, and it already has pre-compiled images for each version of Raspberry Pi. You just need to click, download, and follow the steps on tutorial, which is really simple. You download the app that will prepare the image on the SD card. Choose the image compatible with your Raspberry Pi version, write it to the card, plug it into the Raspberry Pi, and turn it on. And it will automatically set everything up for you. Then all you have to do is load the ROMs, which are the games. You can download them from the internet, upload them there, and then just have fun. On the RetroPie website, there's a forum where people share ideas and help each other out. But there are also a ton of tutorials all over the internet, so I'm not going to go into detail here about installing RetroPie, okay? But here's a heads up, for those of you who've never used a Raspberry before. In this project, the Raspberry is going to draw a lot of power, because it's going to be running graphics, even if they're lighter games. And you're going to need a reliable power supply, since the Raspberry Pi in versions 2 and 3 uses mini USB or micro USB. If I'm not mistaken, it's harder to get it to run at 3 amps, which is what it needs for stability. But in version 4, it already comes with a USB-C port, so it's easier for you to find both a charger and a good quality cable, so you can plug it in and have it run. Nice and easy. If, when you start it up, you see a little yellow lightning bolt flashing on the screen on the monitor, that means your Raspberry is under voltage. In other words, it's trying to draw more power than the power supply can provide. I'll leave the link here in the description so you can buy the power supply and the cable. This is the right one to use with Raspberry Pi 2 and 3. And for the 4, the power supply also works. The only thing is that you can use a USB-C cable. Most USB-C cables are already capable of supporting 3 amps. The biggest challenge is specifically with the Raspberry Pi 2 and 3. Because with the little cable, the one with the micro USB connection, it's harder to actually find one on the market that can reliably handle that required amperage. And trust me, I tested a lot, racked my brain until I found the perfect combination. So, I'll leave the link here in the description so you don't make a mistake and don't waste your money. Project assembled, everything's ready. Now, of course, I'm going to play a little, right? Because nobody's made of steel. Okay, so if you'll excuse me and if you don't mind, I'm going to take a moment to get ready to do a little bit of gameplay. Actually, I think this machine, needs to go over there to work properly. Now that's better. Now I'm going to do my gameplay.